Hey everyone! In this video, I would like to talk about antiderivatives. So the first important thing we need to do is we need to put ourselves in the mindset where we're able to think backwards, because that's what an antiderivative is. So far, everything we've looked at, we've been given a function, and then we were able to find the derivative of that function using a combination of different rules. But now I want to go the other direction. So now we're going to be given a function that is the derivative of something else, and we need to figure out where it comes from. So just to put some notation with that, let's start by saying we have a function f of x, and this function f of x is going to be the derivative of some other function capital F. So what we want to find is we want to find a function capital F of x such that when I take the derivative of capital F of x, what I'm going to end up with is my function that I was given, f of x. So to make sense of this, let's just start off with a very simple example. So going our normal direction, so let's say I want to find the derivative of something. So let's say I know a function f of x, and let's say that that's the function x squared. If I take the derivative of this, using the power rule, the 2 comes down out front, and we subtract 1 away from the exponent. So 2 minus 1, we'd end up with an exponent of just 1 here. If I wanted to generalize that, I could just take a look at the power rule. So if I have x to the a power, the derivative of this, I bring a down out front, and then we subtract 1 from the exponent. Now let's go backwards and let's think about what we need to do to go from this derivative back to our original function of x squared. So to get there, what we would have to do, I need to cancel out the 2 that came down out front. So I would need to multiply by 1 over 2. And then I also need to add 1 back into the exponent. So that will give me my x squared. If we simplify this, the 1/2 and the 2 will simplify to just to 1. And then 1 plus 1, I get my exponent of 2. In our general case, I would need to multiply by 1 over a, that coefficient that's out front. And then in my exponent, I have a minus 1, but then I need to add that 1 back on. So generally, when we're taking the derivative of something, the exponent reduces by 1. When we're finding the antiderivative of something, it's the opposite. So now we're increasing that exponent by 1. Plus, the other thing we need to take into account is that coefficient that's out front. So we may need to multiply by something so that it simplifies the way we want. So for example, let's think of a simple, let's just say h of x is equal to x to the first power. I want to find the antiderivative of this. So let's find capital H of x. So as we just discussed, I'm going to need to add 1 to the exponent. So this is to the first power, so we'll add 1 more to that. So I have the second power. But now this by itself is not the antiderivative, because if I were to take the derivative of this, the 2 would come down out front and I'd have 2x. It has the same degree as what I'm looking for, but it has a coefficient of 2, which we don't want. So instead, that's where this 1/2 or this 1 over a is going to come in. So I do need to multiply by 1 over 2 to make sure everything simplifies the way I want it to. Because now if I take a look at this, capital H prime of x, if I take the derivative, the 2 will come down. We subtract 1 from the exponent. The 1/2 and the 2 will simplify. And now we're looking at our function that we want. All right, so hopefully all of that clears some things up on how we find the antiderivative. Again, just to repeat what I said earlier, when finding the antiderivative, we add 1 to the exponent, which is the opposite of when we take the derivative. And then the other thing you need to think about is, do I need to put a coefficient out front to make sure things simplify the way we want? The one last thing that I need to take into account when I'm finding the antiderivative is the possibility of a constant. Whenever I take the derivative of a constant, we know that that ends up being 0. So when I find the antiderivative of a function, there may be a constant that needs to be included, but we don't know exactly what constant it could be because the derivative of every constant is 0. So whenever I'm finding the antiderivative of something, so in this case over here, capital H of x is my antiderivative, I'm going to include a plus c. And this plus c, this is just going to represent an arbitrary constant. And then when I take the derivative of that, it just becomes 0, and everything still simplifies the way we want it to. All right, now let's take a look at just a couple specific examples to put all of this together. So my first example, I have f of x is equal to 0. So my mindset, I'm thinking backwards. So what I'm thinking about is the derivative of what is going to give me 0. So here we're going to do capital F of x. That's going to represent our antiderivative. And as I was just talking about, the derivative of a constant is going to give me 0. So my antiderivative of 0 is going to just be that arbitrary constant c. Moving on to the next one, g of x is equal to x to the 1/2 power. So capital G of x is our antiderivative. So our process, thinking backwards, so I need to add 1 to my exponent. So 1/2 plus 1, that's going to be an exponent of 3/2. And the second step, I need to think about a coefficient that I would need to include to make sure everything simplifies properly. If I think about the power rule, this 3/2 would come down out front, but I don't have a coefficient of 3/2 in my original function, so I want to make sure that simplifies to 1, so I'm going to include a 2/3 in this case. Because 2/3 times that 3/2, that would simplify to 1, and I also need to include my arbitrary constant c. And the last one, so we have h of theta is equal to the sine of theta. So again, just thinking about the derivative of what is going to give me the sine. So I know the derivative of cosine gives me the opposite of sine. So if I want my antiderivative capital H of 0, the derivative of cosine is the opposite of the sine. So I need to include another negative, and we have the opposite of the cosine of theta. So if I take the derivative of this, I'll end up with the negatives will cancel out, and I'll end up with the sine. And as always, we'll include our arbitrary constant c. So that's how we find the antiderivative. Remember, it's just we're thinking backwards. So we already know if I'm given a function, we know how to find the derivative. But now the question is just reversed. So now I'm given the derivative, and I need to figure out where that came from.